Let x be a continuous random variable with this PDF. Let y be the smallest integer greater than or equal to x. Determine the PDF or the probability function of y. So now notice that x is actually an exponential variable because this is the PDF of an exponential variable. And actually, it's an exponential variable with mean 1 over lambda. Okay. So the CDF we know would just be 1 minus e to the negative lambda x. If this is the PDF, lambda e negative lambda x. So y is the smallest integer greater than or equal to x. So now x is positive. So when x is between 0 and less than equal to 1, y has to be 1 because y has to be an integer greater than or equal to x, and it has to be the smallest such integer. So the smallest integer that is greater than or equal to these x values between 0, greater than 0 and less than equal to 1 will be 1. Now, for example, 2 is also an integer which is greater than or equal to x as long as x is in this range, but 2 is not the smallest because 1 also does the job. So 1 is the smallest integer that is greater than or equal to these x values. Similarly, when x is greater than 1 and less than equal to 2, then the smallest integer which is greater than or equal to the values of x in this range would be 2, and so on. And therefore, in general, y will be equal to k when x is between k minus 1 and k. So you see the value of y, whatever value of y we have here, the x value ranges x is greater than 1 less than that, 2 is 1 less than 3, and on this side you have exactly this. So y is equal to k when x is a bit greater than k minus 1 and less than equal to k. So we want the probability function of y. So probability y is equal to y. So now I've just replaced this k with y, little y. Probability y is equal to y would be probability x is greater than y minus 1 and less than or equal to y. So that means capital F of y minus capital F of y minus 1. It's a lot easier to use CDF as always whenever we can. And f of y is just 1 minus e to the minus lambda y, and minus f of y minus 1 will be 1 minus e to the negative lambda y minus 1. So when you distribute this negative, the ones cancel out, and this one comes out as positive. So then I distribute this. So this is e to the negative lambda y plus lambda. And then this one minus e to the negative lambda y. And from these two, I factor e to the negative lambda y. I'm left with e to the lambda from the first one and negative 1 from the second one. And y, as we can see from here, takes on the values 1, 2, 3, and so on. And this is choice B.